How does your Switch play NES games? Today we're going to dive into the world of emulators. Welcome to Kopek Explains Software, the podcast where we make computing intelligible.
All right, Dave. Today we're going to be exploring a common software project, ones that you've worked on in the past and are even working on now. How does an emulator work? And I guess we should really start first with, what is an emulator?
An emulator is a way of simulating one computing system on another. For example, a lot of people play video game emulators. So maybe they have a personal computer, but they actually want to play Nintendo Entertainment System games. So they have an emulator that simulates a Nintendo Entertainment System on their personal computer.
It kind of lets you go back and experience, maybe through nostalgia, experience games or things that you've had in the past and maybe don't have access to anymore.
Absolutely, and there's also a lot of practical uses for them beyond just video games. For instance, if you're developing an Android app, you don't want to, every time that you run it, have to install it onto an Android device. So, Google ships an Android emulator that allows you to try out your program right there on your personal computer in a little window that is simulating an entire Android device so that you can have a quick test and refresh cycle. You go change your app a little bit, you right away can see what it's going to look like, try it out a little bit before you go and through the entire process of getting it onto a real device. So there are both really fun applications of emulators, like video game emulators, and I'm sure we'll talk more about them, and there's also some really practical applications too.
So they can be really useful tools for building, for other things that you're building, if you can create this other environment on a different device.
Right, exactly. I'll give you another really common application of them. Back in the late 90s, early 00s, there was a very popular emulator called Virtual PC. What it allowed you to do, if you were a Macintosh user, it allowed you to run Windows on your Mac. And there's a difference between what Virtual PC was doing and what something today like VMware Parallels is doing. Perhaps some of our listeners have heard of those. Those are virtual machines, and we'll talk about the subtle distinction between what they do and emulators later in the episode. But the point being that, sometimes there's a device that you don't have right in front of you, but you really want to run software for that device. So what an emulator does is it simulates the hardware of the device that you don't have access to, therefore allowing you to run the software for that device on your other device.
So there are a lot of different uses for them, and it's going to be something really common that a software engineer or a programmer might be working on or might be utilizing in their toolbox is an emulator.
Yeah, so software developers are going to use them on a regular basis when developing for platforms that are different from the platform that they're actually writing the software on, like the Android emulator that we mentioned earlier. Mm-hmm. People who need to run software for computing systems they don't own are going to run them regularly. But we also see them a lot in video games. So for example, if you own a Nintendo Switch, Nintendo has a service called Nintendo Switch Online or Switch Online, and it allows you to run Nintendo Entertainment System games, that's their console from the 1980s and early 1990s, and Super Nintendo games, that's their console from the early 1990s, right there on your Nintendo Switch. Now, the Nintendo Entertainment System and the Super Nintendo had totally different architectures than the Nintendo Switch. They ran on these old microprocessors called the 6502, the Nintendo Entertainment System, for example. That is such a different architecture from the ARM microprocessors that the Switch has. So you can't just go and take Nintendo Entertainment System software and run it on the Switch just raw on the bare metal of the Switch's ARM microprocessors. So what you do instead, what they do through their emulator, is they go and recreate that 6502 microprocessor in code. So they have software that simulates all the different things that the 6502 microprocessor does. But wait, it doesn't just stop there. They also have to simulate the graphics hardware from the Nintendo Entertainment System. And they also have to simulate the audio hardware from the Nintendo Entertainment System and the joypads from the Nintendo Entertainment System. Every component of the hardware has to be recreated in software. And then, once they've recreated that base, on top of that recreated hardware and software, they can run the games from the original Nintendo Entertainment System. Now, the original games are, of course, software. So you have software running on what it thinks is the original hardware, but is really just other software.
What's really cool about emulators is it's a place where really the hardware and the software intersect in some different ways. Like the idea that you're using software to create this hardware environment is something that's pretty unique.
It's kind of like a translation layer. So it's kind of like a way of saying, hey, I want you to run this instruction from the 6502 microprocessor. And the emulator goes and says, well, you know what? I know how to run that by running these instructions on the ARM microprocessor. So it's going and translating what the software wants it to do on the old hardware into ways of doing it on the new hardware.
So can you do this for any kind of software or hardware that you want to create? Are there any legal issues?
Yeah, so you can do this. Any computer can be simulated on another computer. But the difficulty sometimes comes around with both performance and legal issues. I think we'll talk more about some of the performance issues a little later, but the legal issues can be significant. Let me tell you about a few of them. Now, you can go and simulate hardware in software by reverse engineering it. As long as you don't have any secret confidential plans about how the hardware works that you stole, you can go and simulate that original hardware. But the software, you can't just go and copy. So, for example, let's go back to our Nintendo example. A lot of people don't just run Nintendo Entertainment System emulators on their Switch. They also run open source ones on their personal computer. And then they want to go and run the original software. So maybe they want to get a game of Super Mario Brothers, or they want to get the original Tetris going and running in their emulator. Well, the problem is that even though it's okay that the hardware was reverse engineered because nothing was copied to do that reverse engineering, the software, you can't just go and copy that old software. That is under copyright law. That's protected. And Nintendo is actually pretty aggressive at going after ROM sites, so-called ROM sites that have big directories of old Nintendo games. The people who created that software still own the copyright to it, and they can sue you for copying it. Now, people get away with it all the time, obviously, and the emulation scene in video games has been really active since the mid-1990s when the first Nintendo Entertainment System emulators came out. But it is technically illegal. And we see this now about newer systems. So now you're seeing emulators coming out for systems like the Nintendo GameCube, or the Sega Genesis, or the PlayStation, or even more recent systems like the Nintendo Wii. There's now a pretty good emulator for the personal computer. So people are going and actually downloading games for the Wii that they didn't pay for and then running them on these emulators. And you can see how that is a real problem for the commercial interests who created those games.
So it's not the act of reverse engineering or building the emulator, but it's really what are you doing with the software, how are you getting it, and not doing anything that's sneaky or against the rules.
Right, the reverse engineering is legal, but copying the software is the illegal part. But what use is the emulator without any software? So why would you even want to have the emulator if you don't have the original games to run on the emulator? So in essence, it's pretty impractical unless you're going to go and actually download the software. However, there is a kind of a loophole here. So if you own the original software, you then, it's actually pretty much okay. I'm not a lawyer, so don't take my word for it. But if you own the original software, it's okay that you have a copy of it on your own computer. So for example, if I have an original Super Mario Brothers cartridge for the original Nintendo Entertainment System, like a physical cartridge, and then I use hardware to copy a version of that software from the cartridge onto my computer, and then I run that in an emulator, that's okay. But if I go and don't have the original cartridge and I just download Super Mario Brothers, that's illegal.
So let's say I've thought about all the legal issues and I've decided I actually do want to build an emulator. I'm ready to reverse engineer it. How would I go about writing one? Where do I start?
So writing an emulator is pretty involved because remember, you have to really understand that original system that you're trying to emulate because you have to recreate all of its hardware in software. So you have to pretty much understand all of the chips on the original emulator. We talked earlier about the Nintendo Entertainment System. That's one I've actually written an emulator for. I didn't write a great one, but I wrote one that was able to play Super Mario Brothers and Donkey Kong. So to write that, I had to understand the 6502 microprocessor in the original Nintendo Entertainment System. I had to understand the memory model of the Nintendo Entertainment System. I had to understand the graphics of the Nintendo Entertainment System, which is another chip called the PPU, the Picture Processing Unit, which is actually almost as complicated as the microprocessor. And then I never really got my audio working well, but you also need to write the audio processor as well. So you have to understand all those chips. Now, the Nintendo Entertainment System is a really simple computer. It came out in 1985. It's in the US. It's a really pretty straightforward, pretty simple computer. If you're trying to emulate a modern computer, it is like another order of magnitude more complicated. So the difference between the knowledge and skills that you need to emulate the Nintendo Entertainment System versus, let's say, the Nintendo Switch, if you were going to write a Nintendo Switch emulator, is like next level. It's totally another ballpark. I'm not even sure that one person working on their own would even be capable of writing a Nintendo Switch emulator.
Okay, so it's a daunting challenge. And it really requires you to understand not just the software of a computer, but really the hardware. Like, you really need to know exactly what each little physical piece of the computer is doing in order to create software that's going to mimic it.
That's exactly right. And, sometimes you can get away with being a little bit off and some of the software will still run. But, there's also times where if you're just missing one instruction and, the microprocessor might know how to do hundreds of different instructions. But if you just run one of those instructions even a little bit off, then the software, when it tries to run that instruction, is not going to get the result that it expects. And the whole thing is going to fall apart. And so it can be pretty tricky, and the level of precision that you need when you're writing an emulator is really quite high.
I think one of the cool things that I've seen in the emulators that you've built and the projects that you've worked on is the community and collaborative aspect that there can be to it. And that, I guess, could be really useful when you're taking on this big project as a resource. And then you've also used like manuals, I guess, to really understand what each command is in the computer. Is that accurate?
Yeah, so there are some great communities around certain devices that people really are interested in emulating. So for example, the Nintendo Entertainment System has an active community of people writing emulators and kind of helping each other and spreading documentation. So does the Game Boy, so do some of the Sega systems of the late 90s and early 90s. However, there's also official documentation, like you mentioned, from some of the parts manufacturers. So for example, the Nintendo Entertainment System had a 6502 microprocessor in it. It was made by a company called Moz Technologies. Well, a lot of devices had that microprocessor in it. It was a really generic microprocessor. It was in the Apple II. It was in the Atari 2600. It was in several other personal computers that were sold into the home and education market. And so there's a lot of documentation about that microprocessor. They're not necessarily specific all to the Nintendo Entertainment System, but because it's the same generic part being used in all these different systems, there's whole books written about that microprocessor. So there is a lot of official documentation you can come across for some of the individual components. Now I'm working on an IBM PC emulator for the original IBM PC that came out in 1981. So that uses a bunch of Intel parts, including an Intel microprocessor called the 8088. It uses all kinds of timing chips and interrupt controllers from Intel as well. And Intel didn't just sell those devices to IBM, they also sold those chips to a lot of other companies. So they published huge official manuals. We actually have one here in the room with us. It's like 600 pages on some of their different microprocessors and devices. And that was put out there so that hardware manufacturers would know how to use those devices, but they're also incredibly helpful to emulator developers because then we can understand all the intricacies of how the original hardware manufacturer intended for the hardware to be used. So building an emulator can be a lot of just reading and wading through the documentation. I'd say that's a huge, huge part of it. And before you even get started, you really have to wade through some of that documentation to get a handle on how the different parts work and fit together.
So let's say you do all that homework and then you build your emulator and you're really proud of it. Is it as good as the actual real machine?
Unfortunately, almost never. Now, there are going to be some things that are actually better about sometimes an emulator than the original system. I'll give you an example. When you write an IBM PC emulator, you now can download software on the internet to run on it, right? Instead of having to go to a store to buy all your software for it, right? So that's really nice that you have that immediacy and this huge catalog of software you can run on your emulator that back in the day you would have had to go to a store or get through the mail to actually use on it. Also, there can actually be enhancements that you create. So for example, with a video game emulator, you might be some games that didn't originally have the ability to save your progress. You can actually save the exact state the emulator was in while you were playing the game and then go back to it at a later time. So there can be some parts of it that have enhancements, but there also are some limitations. One of the biggest limitations is that it's very hard to be 100% accurate. So to recreate every intricacy of the original hardware in software is a big challenge. And even systems that are not that recent, like the Super Nintendo, still emulator authors struggle to make every single game for the original Super Nintendo play perfectly in an emulator. Because even though the hardware was pretty simple by today's standards, it was still complex enough that it's difficult to get every single detail right. Then there's also performance considerations. So basically, the more powerful the system that you're trying to emulate, the harder it's going to be to emulate it in real time. So as fast as it was supposed to be when you were actually using the original device. For example, it's very, very difficult on a modern PC, probably impossible, to let's say go and emulate an Xbox 360 perfectly to the point where every single game would play at full performance. It's just that was a pretty recent system. It had a tri-core PowerPC chip in it, I think running at multiple gigahertz. It's just almost impossible when you're doing that translation layer, because remember, an emulator adds another layer between the software and the real hardware where you're doing translation of each instruction as you go through. It's very hard for that translation layer to be fast enough to actually emulate the system in a reasonable amount of time. Now, there are tricks. So for example, in the late 1990s, one of the most powerful consoles at the time was the Nintendo 64. And people were stunned when, I think it was 1999, a Nintendo 64 emulator for the PC came out. People were like, how is that even possible? There are tricks. There's ways of kind of taking some shortcuts and not being as accurate, and instead still getting something that works, but that isn't necessarily going to have every pixel look exactly like the pixel looked on the original device. So there are tricks, but there are real performance limitations. So a PC, let's say, running at, on a modern microprocessor is not probably going to be able to emulate a video game system running at the same speed, a modern video game system. It would just be too much overhead in that translation layer for it to work.
So when you're going into one of these projects, you just have to be aware that you can get close if you put in a ton of work, but it's never going to be 100% the same, but it's still a really worthwhile programming project and experience, and can be really useful as a tool, particularly when in terms of like the Android environment, when you're programming for something else.
Yeah, I mean, it's a great programming exercise for developers to do, because you really learn a lot about the low level of how the original device operates. For something like the Android emulator, Google, I'm sure, has a huge team working on it, a lot of engineers, and there's some really practical emulators. But probably what people are more familiar with today are virtual machines, which aren't quite the same as emulators.
That's actually my next question, is what is a virtual machine and how does it differ from an emulator?
Virtual machine is a little bit more of a generic term than an emulator. So with an emulator, we usually think about we're trying to simulate one computer on another. A virtual machine is more like just an abstraction of the machine. We don't necessarily have to always simulate every single piece of the original device when we're talking about a virtual machine. I'll give you an example. Oftentimes people run software called VMware to be able to run Linux on their Windows device or run Windows on their Mac. Now, usually those devices are running on the same microprocessor architecture as the operating system that they're trying to run. Therefore, when you use VMware, it does not need to go and simulate the microprocessor in the same way that your Nintendo emulator has to go and simulate the 6502. because both of them were intended for Intel microprocessors running the x86-64 architecture, it has to simulate other layers, maybe other hardware devices, but not the microprocessor itself. So it's saving some of that translation layer. And therefore, it can run much more efficiently without the same performance hurdles that we talked about earlier. So virtual machines are used all the time. There's going to be an issue actually pretty soon because Apple is switching its microprocessor architecture from x86 Intel microprocessors to its own ARM architecture microprocessors. And so virtual machines won't be able to run the x86 version of Windows on Apple's new microprocessors. If we wanted to do that, we would then have to use an emulator that was going and emulating the original Intel microprocessors to run that x86 version of Windows. Now, Microsoft has recently come out with an ARM version of Windows, so it's yet to be seen if we'll be able to run that version in a virtual machine on Apple's new computers.
So virtual machine doesn't require the same level of translation.
Right, it's a more generic term, and usually the virtual machines that we use don't require the same level of translation. However, we could also say technically, just to be technical, that emulators are virtual machines. So it's kind of like an emulator is a virtual machine, but not all virtual machines are emulators.
So would you have any advice for someone who wants to take up an emulator project, maybe one that you think is great to start with, or one that you've really enjoyed learning about or working on?
So writing an emulator for the programmers out there is a very involved task. And I would say before you do it, I would have experience with some kind of low-level language. C or C++, ideally maybe a little bit of assembly language as well. And I would also spend a lot of time reading the documentation and also joining one of these communities. So especially if you're going to do one of the popular systems like the Nintendo or the Game Boy, and really getting to get some of that peer advice as you go through building the system. If you are somebody who uses video game emulators, my advice to you is to be careful about the legal issues. You're welcome to download emulators, but if you don't own the original game, you have to think about whether when you download that game, you're actually doing a bit of a copyright violation. Now, should Nintendo be going after people for their 30 or 40-year-old software? That is, I guess, a moral issue that we each need to think about on our own terms. But the law is pretty clear. If you don't own the original game, you shouldn't probably be downloading it. All right, well, I want to remind people to follow us on Twitter. What's our Twitter account handle?
@Kopek Explains.
Yeah, and we don't have any followers really yet, so please follow us. But we are getting reviews on Apple Podcasts and on Overcast, so we really appreciate that, and that really helps with the podcast. So please do leave us a review on your podcast player of choice. You can also find us on Spotify and Google Podcasts, wherever you're listening right now. Leave us a review. It really does help out, and we look forward to seeing you next week.
Thanks for listening.